In this video, we're going to do all of the solving radical equations problems from Unit 6.5 from the Unit 6 review. So let's start with question 20. We're going to need to solve this expression, and as we're solving it, we're going to need to list the properties that we're using from the word bank in your review sheet. So let's start. We need to get this x alone. It's currently inside a radical, having 7 subtracted from it, being square rooted, multiplied by 2, and having 7 subtracted at the end. The very first thing we're going to have to do to get inside to see that x is to add 7 to both sides. That is the addition property of equality. I'm going to use some abbreviations here. When we add 7 to both sides, we end up with 4 equals to square root x minus 7. And now we're ready to get the radical away from that 2 that's being multiplied by it. So we're going to have to divide both sides by 2. That's the division property of equality. Okay? Which means we're going to have 2 equals the square root of x minus 7. Now we're going to need to undo that square root. We have isolated our radical. That would be considered step 1 of solving. Now we need to undo the second root by raising both sides to the second power. In the property list, that's called square both sides. In our set of instructions, that's called raising to the index. Once we do that, we end up with 4 equals x minus 7, and we're ready to do our last step, which is going to be, again, to add 7 to both sides. That is the addition property of equality. And we end up with x equals 11. Let's go ahead and take a look at number 21. We're going to solve for x and list our steps as we go. So first and foremost, we should isolate our radical, but lucky for us, it's already been isolated, which means we're ready to go ahead and get the radical out of there by raising both sides to the reciprocal. In this case, the reciprocal, not the reciprocal, wrong word, raising both sides to the index. So the index of this problem is the number 4, so since we're doing the 4th root, we can undo that by doing the 4th power on both sides. And we can say that is raise both sides to the 4th power. So if we do that, the 4th power and 4th root will cancel. We get 2x plus 6 by itself, and 2 to the 4th power is 16. 2 times 2 times 2 times 2. Now that we have undone our radical, now we just have to solve for x. So it's being multiplied by 2 and having 6 added to it. We're going to subtract 6 from both sides. We end up with 2x equals 10, and that was the subtraction property of equality. And last but not least, we have to divide both sides by 2, which is the division property of equality. And it gives us x equals 5. Alright, let's go ahead and check out question 22. 22 and 23 are similar, except instead of our equations being in radical form, our equations are in exponential form, which means we're going to have to use the alternate step 2 to finish solving these guys. But step 1 is the same. So step 1 is still isolate the radical. So in this case, we're going to have to add 3/4 to both sides. There we go. So that's the addition property of equality. We end up with 2x to the 1/3 power equals negative 11 plus 3, which is negative 8 over 4. And we can simplify that a little bit. That's not a property, but we can simplify 8 over 4. 2x to the 1/3 is negative 2. Now we're going to have to undo that radical. Undoing that radical, we're going to have to use that alternate step 2. So instead of raising both sides to the index, we'll have to raise both sides to the reciprocal. And the reciprocal is the upside down of our exponent. So instead of 1 over 3, our reciprocal is 3 over 1. And we're going to have to do that on both sides. So that is raise both sides to the 3rd power. We have to be specific with our numbers over here. Now, if I raise the 1/3 to the 3rd power, that's going to end up just actually raising me to the 1st power, which is going to turn invisible, so my 2x is completely unlocked. Now all I have to do is negative 2 to the 3rd power. Negative 2 times negative 2 times negative 2 is negative 8. And I'm ready to do my last step, which is just to divide both sides by 2. So that's the division property of equality. And my final answer is x equals -4. And now we just have one more problem to take a look at, and that's question 23. So 23, we're going to start with the same first step, isolate the radical. So we're going to have to subtract 1 from both sides. That's the subtraction property of equality. And that's going to give us x to the -1/4 equals 3. Now, I've seen a lot of people rewrite the x to the -1/4 in this step, but we don't want to do that because x is still inside that exponent. I don't want to use any negative properties until after x is by itself. So we do want to undo that -1/4 power, and we're going to do it by raising both sides to the reciprocal. So my exponent is -1/4. The reciprocal of that is -4/1. It doesn't matter where the negative is, as long as the fraction is negative and we flipped it upside down. So we're actually going to raise both sides, the -4th power. The -4th power will turn the -1/4 power into just the first power. It will disappear. And now all I have to do is 3 to the -4th power over here. So what I did is I raised both sides to the -4th power. Now we just have to finish solving, and the way that we're going to do that is by using the negative exponent property, which is what we learned in 6.4. The negative exponent property says that a base to a negative exponent should actually be in the denominator. So my x equals will stay the same, my 3 and my 4 will stay the same, but they should move to the bottom of a fraction. And as soon as I've done that, this horizontal line that makes my fraction bar is the same horizontal line that made my negative symbol. And once I turn it into a fraction, then I don't need the negative anymore. Now all we have to do is finish solving by actually raising 3 to the 4th power. 1 over 3 times 3, which is 9, times 3 times 3, which is another 9, which gives us 1 over 81, and that guy's all finished. All right, we're going to keep on keeping on with graphing radical equations in the next video.